Hey there everybody, welcome back to the channel. So we did this one previously. On to the next problem. Let's see what it is. LeetCode45 jump game 2 medium level problem. Let's see what it is offering. We are given with a zero indexed array of integers, nums of length n. Okay, we have an array of length n with integers in it. You are initially positioned at index 0. Okay, each element in nums represent the maximum length of a forward jump from index I. Great. In other words, if you are in index I, you can jump to any index where 0 is less than or equals to j is less than or equals to the element. So we can choose not to jump, and I plus j is less than n. 5 plus j. Okay, return the minimum number of jumps to reach index n minus 1. The test cases are generated. Okay, so let's see the example. We have 2 3 1 1 1 4. The jumps to reach the last index is 2. Jump one step from index 0 to 1. Okay, got it. So currently we are at 2, initially at position 0, and at position 0 we have 2. So we can have 0 steps, 1 step or 2 steps, and we can go to 1 or 2. But if you go to 1, then you have to jump 1 again and then 1. It should make 1 2 3 steps. Instead, what we did is we just jumped 1 step forward. Which then helped us move forward to 4. And let's see the constants. The length of nums will be between 1 and 10 to the power of 4. So the nums of elements will be between 0 and 1000. It is guaranteed that you can reach resource n minus 1. We can, I think we should compare every step. But if we do compare every step, it won't become a greedy problem. Let's see. If we think greedily at position 2, you have to move to position 1. So define position if position for I in range of nums of position starting from 1 to 57. And this would cost now I guess we have to count the moves position infinity on type of Mm. Minimum of represents so for 2 we'll do position 0, sorry, 0 plus 1 and 0 plus 2 at 1. We go through 1 to 3, 1 plus 3, 1, 2, 3. Something is not going right. Uh, I think this sure is a DB problem. I happened to learn about this LRU cache thing for an interview. It will be very handy for DB problems. This should make 3 jumps. If length of nums equals to 1, let's submit this and see how our solution is working. And let's see other solutions as well. And I am itching to see what is the topic of this problem. I am submitting it. Oh, should I expected this? I just thought of making a edge case, but anyway, let's it off noise. If noise is less than 3, well, if it is of length 3, we should jump at least one step. Or if it is 1, we don't need to jump a step forward. Let's submit this again. But I'm sure it will pass now because we are very close. Maybe 17 test cases out of 110, which is a probability of around 90, 85 to 90%. Uh, Let's think of a way to pull this off. Let's see the topics. Yeah, said right. Let's ask GPT to optimize it. Well, at least I got to learn something. Be optimized. Current code is top-down recursive DP that explores every possible jump. Although correct, it's still order of n square in the worst case, and Hinka's recursion plus cache over. Let's go through it step by step. Okay. What you can do at each position, you try all possible jumps. You memorize by position, but also carry jumps, which creates unnecessary cache key combinations. Thus, even with large many overlapping calls and deep recursion persists. As well, greedy solution that achieves linear time. You don't need to explore all paths. You only need to track the farthest point reachable with the current jump range. And when you reach the end of the range, increment your jump count and extend the range to. You only need to track the farthest point reachable with the current jump. And when you reach the end of the range, increment your jump count and extend the range to the farthest point concept one. Current and farthest 0. So n minus 1 farthest equals to maximum farthest end I plus nums of I. When we reach the end of the range, if I is the current end, jump plus 1. When we reach the end of the range for current jumps, wait a minute, when we reach the end of the range for current jump, go to the next jump, current end equals to the farthest. Okay, we jump to a farthest point. Wait a minute. Farthest comma I plus nums of I. We don't need to check from 1, right? We don't need to check from the position 1. It is change between 0 and nums of I. Okay. And understand again. Farthest. You are efficiently performing level of the travel for the by particular. It will correspond to one jump. Example, jump 1 from index 0 up to 2. Jump to okay. Reach index 4. From 0 to nums of I. Okay. If I equals to the current trend, which is 0, we go it will cause the problem. For example, if I take this nums of I is 2, 1, 2. If we jump to the farthest position, one plus nums of 1, you only need to track the farthest point reachable within the current jump range. and when you reach the end of that range, increment your jump count. For just let's dry run it and see. For this, if you take double two, initially we are at 2 and the farthest point is maximum of 0 comma nums of I, which will be 2. No, the farthest point is 2 and I is current end, which is 0. Both are 0 0. So we jump to the position. Now the current end equals to 2. Now we go to 1. Farthest point from, okay, farthest 2 comma 1 plus nums of I, which will be 4. So farthest will be 4 here. If I equals to the current end 1, the current end is 2 currently. It is kind of checking all possible jumps. So basically what we're doing is in starting from 0 to n minus 1 position, which Right, we don't need to check for n-1th position, because if it is already there, then I guess we don't need to make any jump. So we're checking until n-2th position. Longest possible jump until that point. I couldn't thought of a better name other than farthest. Let's keep it current position. Now we call the farthest. We just wanted to make the farthest possible jump that happened until that point, and along the way let's count the number of jumps we did. Just like that. Even though we jump to a undisclosed position, we are calculating the farthest position that we could have gone to until that point. Before actually going to the current position, and we are updating it. So we are making the farthest possible jumps, and we are counting them as we go. Let's submit this. Let's see. Let's see other solution as well. It seems like everybody is cut out of the same cloth. This can be helpful. So we don't need to continue any further. Should make it even more faster. That's a significant upgrade. So that's it, guys. I hope you guys understood the intuition. What's happening here is, let me clear again everything. We are going through each and every one of the positions until n minus second position, because we don't need to check if it already reached the destination. So we are calculating the farthest point that could have gone with a selected position until a position. So we are checking from first position what is the farthest point I can go, and for the second position what is the farthest point I can go, third, fourth, and until we reach the destination. We are calculating the farthest point, and if I reached the current position, which would be the farthest point until that point, we have to move forward anyway if we reach the eighth position, and we choose to move to the farthest point, because if even if the farthest point didn't change, the current position will always be the same. It should change if I is at the farthest point, then I plus nums of I will for sure greater than the farthest point, because if I equals to the current position, which would be the farthest point, we are adding something to it, so we should be further away. And along the way we are calculating the jumps, and it is the case when we prematurely reach the end and don't want to continue anymore as we reach the end. we are returning the answer, or else we can jump slowly until the last and return the answer. So that's it, guys. I hope you guys understood the intuition. If you like the video, upload it and share it with your friends, and don't forget to subscribe to the channel. We'll meet you again with another video. Until then, keep learning and keep pushing hard. And thank you for choosing the channel, guys. If you comment for the video, it would be even better. And thank you, everybody. Goodbye.